Hi, in this video we will show you how to model and simulate an MD1 queue in NetSim. Following Kendall's notation, an MD1 queuing model represents a system where arrivals are a Poisson process with arrival rate of lambda arrivals per second. Service time is deterministic, or in other words a constant value equal to mu, and the system has one server. Let us start by creating a scenario to model the MD1 queuing network. A simple internetwork with one source, one router and one destination will be used as our network scenario. We navigate to create a project by clicking on Simulation New Internetworks. A grid-based environment is displayed on the screen. We place two wired nodes and connect them via a router using wired links as shown. To ensure the equivalence to an MD1 system explained above, the arrival of packets should be Poisson and the node's buffer acts as a queue. The link acts as a server since it transmits or serves the packets arriving. There is only one server since only one link transmits or serves all the packets arriving. Right click on wired node 1, select properties, and a window will appear having sections shown per the 5-layer TCP/IP stack. Set the destination to be node 2 and select custom traffic type. Here, set the packet distribution as constant, the packet size as 1250 bytes, the packet inter-arrival time at 2000 microseconds, and the packet inter-arrival time distribution as exponential. The constant packet size ensures that the transmission time or service time in the link is constant, while the exponential distribution for inter-arrival time ensures a Poisson arrival process. Click Accept. Disable the TCP protocol in the transport layer and click on Accept. In link 1 and link 2, change the uplink and downlink speeds as 10 Mbps, uplink and downlink bit error rate as no error, and uplink and downlink propagation delay as 0 microsecond. These values are set since the service time depends on the link speed, and we don't want the links to be so fast that queuing is negligible. Right click on router properties and accept default properties. Now we click on the simulate button, which opens a window where we enter simulation time of 100 seconds and the experiment name. We leave the seeds at their default values and run the simulation. Observation: as the 1250 byte packet moves through the layers, some overhead gets added which results in an increased packet size. This is the actual payload transmitted by the physical layer. The overheads added in the different layers are transport layer 8 bytes, network layer 20 bytes, MAC layer 26 bytes, and 0 bytes at the physical layer. Therefore, the total overhead added becomes 54 bytes, which increases the packet size to 1304 bytes. Theoretical calculation: by formula, the queuing time T is equal to 1 by 2 nu into rho by 1 minus rho, where mu is the service rate and rho is equal to lambda by mu. Service rate mu is given as link capacity in bits per second divided by payload in bytes into 8. This is 10 into 10 to the power 6 divided by 1304 into 8, which gives us a value of 958.59 packets per second. Inter-arrival time is equal to 2000 microseconds, and the arrival rate, which is equal to 1 upon the inter-arrival time, turns out to be equal to 500 packets per second. Rho is the utilization, which is lambda by mu, and lambda is 500 and mu is 958.59, which gives rho value of 0.522. Applying this in the queuing time formula, we get the total queuing time is equal to 569.61 microsecond. Now let us look at the output of the simulation. After running the simulation, click on the application metrics and check the mean delay. We see that the mean delay value is 2656.828 microsecond. This mean delay is the sum of queuing delay, transmission time and routing delay. The total transmission time is the sum of transmission times through link 1 and link 2 and is equal to payload in bytes into 8 divided by uplink speed in bits per second, which is equal to 1043.2 microsecond. Router delay is the time taken by the router to route the packet. In NetSim, this value is set to a default value of 1 microsecond. Therefore, we see for the simulation the total queuing delay is equal to 2656.828 minus 2 into 1043.2 minus 1, which gives a value of 569.428. Now we noted that the theoretical value was 569.68 and the value from NetSim is 569.42. As you can see, the value is equal to the theoretical value predicted within an accuracy of plus minus 0.5%. This very small difference is on account of network startup effects before reaching steady state. Users can run simulations for longer periods of time to obtain higher levels of accuracy. Hope you enjoyed this video and thank you.